4.2 logarithmic functions. Alright, so now we're going to find the domain of each function. Now you have to remember that the argument of this logarithm can't be 0 or below. So you can't take a logarithm of 0, basically. So what we're going to do is we're going to take this argument, the x minus 5 here, and we're going to set it greater than 0. Right, and then we're going to solve this. So plus 5, whatever we do to one side of the equation, we do to the other, gives me x is greater than 5. So in this case, we know this whole entire thing is going to be greater than 0. This one's a little bit more difficult conceptually, but not that much. So the thing about this one right here is that we don't want this to equal to 0, right? So if x is equal to 13, 13 minus 13 is 0, 0 squared is 0, and we can't have the argument 0. Now the thing is, if it's less than 0, this whole entire thing is less than 0, the thing within the parenthesis, then when you square it, it's going to turn positive, and that's okay. And the same thing is also true if x is greater than 13. Again, that's okay. So basically, it'd be shorter just to say that x cannot be equal to 13, right? So over here, we're saying evaluate the expression without using a calculator. Okay. Now, we didn't really go over natural logarithms yet, but natural logarithms have an understood base of e, right? So the base here, even though you don't see it, is e. It's like that, right? So evaluate the expression without using a calculator. So you basically say, well, e to what power would give you e to the 5th power? Well, I mean, 5, right? Or to put it another way, so that you could do a log base e, which is a constant. See? So again, whenever we're dealing with this, it's just, if you see a natural log, ln, its base is understood to be e, right? So it's a log within a base of e. That's some kind of interesting properties later on. Okay, now this is another instance where we have a natural log. So again, that's basically saying this natural log has a base of e, and it's equal to e to the 18th, right? And the question is, what's that equal to? Well, let's manipulate this a little bit to make it to write that as a fractional or a negative exponent in this case, right? So that's really, if you have e to the 18, we could just take this entire denominator, put it on top, and that gives me e to the negative 18th power. So let's just rewrite this entire thing here. So say log base e to the negative 18. And that actually tells you what it is, right? So what is it? It's that. It's negative 18, right? Over here, again, kind of similar situation. And that the base here is understood to be an e, 6x, right? And that's the question, right? Now, once you get the hang of this, you can kind of look in this case right here, well, e to what power will give you e to 6x? Well, 6x. And right here, the same kind of thing. Well, natural log is e there, right? So it has an e base. So we'll give you e to the 5th, 5. So if you notice that you can just take this, when this base and this, right, the base and the base of the argument here match, you can just take that, right? And that's true. Same thing on this one. Just put it over here. Good. So we end up with 6x. All right, so let's try this one. Write the equation in its equivalent exponential form, then solve for x. All right, so let's try that. So first of all, what's the base? Well, the base is 5. What's the exponent? The exponent is 2. What is the argument? It's going to be what it's equal to right here. So we say x minus 4. Okay, we can solve this, right? So 5 squared will give you a 25. And that gives us x minus 4. And then we solve for this x by saying plus 4, cancel, cancel. And we end up with 29 equals x. Oh, awesome. Then we can plug it in if we wanted to verify this, right? So we say 29 minus 4 is 25. All right, so go over here. Find the domain of the logarithmic function. Okay, now the key is we want this argument to be greater than 0. It cannot be negative and it cannot be 0, right? So we would simply say, well, x squared minus 2x minus 8 is greater than 0. So we can factor this out, right? So we'd end up with x, and we'd end up with an x. So we're looking for two numbers that we can multiply to give you a negative, which means one's going to be positive, one's going to be negative. That if we add together, we give you a negative 2. So what two numbers would those be, right? Well, the stronger one has to be negative. So it looks like it's going to be a 4 and a 2, right? Because the difference between a 4 and a 2 is a 2. Now, because the middle term is a negative, the 4 must be negative, and the 2 must be positive. Okay, so we solve for this, right? So x plus 2 is equal to 0, minus 2 minus 2. Cancel, cancel. So we end up with x is equal to negative 2. Over here, we'd say x minus 4 is equal to 0, plus 4, plus 4. Obviously, you just could have flipped the signs. That would have been easier. But if you wanted to write it out here. But it's not that simple, right? Because we need to know which parts of this to include in our domain. Now, one way is to do a test. So you can say, like, this is part A, this is part B, this is part C, dot, 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 dot. And you would do a little test pointing in between there. Now, because we know a parabola either looks, and this, if it's positive, it looks like this, and if it's negative, it looks like this, we know the legs are going to be in the same direction, so they're going to match. So technically, we were going to be able to figure this out with just one part. So for instance, if this is true, the other one must be true. If this is false, the other one must be false. And this one in the middle is going to be the opposite. But we'll just do the math the long way, and then I'll show you how you could have used a shortcut to figure this out. Okay, so let's say my test point here is going to be a negative 3. Test point here is going to be a 0, and test point here is going to be a 5. Okay, here we go. So first test point. First step point is a negative 3. All right, so we're going to say, I'm going to use the factored form just for funsies. All right. So I just took the factored form here and I plugged in the negative 3, and then we're going to verify this is greater than 0. So negative 3 plus 2 is negative 1. Negative 3 minus 4, right, is negative 7. And that would give me a positive 7. Positive 7 is greater than 0. Now, technically, you don't even have to find the number here. You can just find the sign. So negative times a negative is a positive. That's all we needed to know, and that's fine. Okay, so the first one turns out to be true. Now, again, technically, at this point, we know the other leg has to be true, and this is probably going to be false, right? But we're just going to verify it with the math. Okay, so let's say we plug a 0 in. 0 plus 2 times 0 minus 4 is greater than 0. So we would say 2 times negative 4 is greater than 0, which 2 times negative 4 is negative 8, is greater than 0. Ooh, that's false. That's a false. Just like this was a true, this one's a false. Like I said, we're going to put false there. Now, that's what we predicted, though, right? If that's true, that has to be false. So it's the first part and the last part are the same, and the middle is the opposite, right? Because, again, we should know the parabola, right? So, for instance, if it looked like this, if I drew it on like a rectangular coordinate system, you could see, right? If it hits here, and here, these are going to match, and this is going to be the opposite. Or if I put it the other way, here and here, same kind of thing, matching, matching. This little interval right here is going to be the opposite, right? Above or below, right? Okay, so we try the next one, which in this case is going to be a 5. 5 plus 2 times 5 minus 4 is greater than 0. So it's 7 times 1 greater than 0, which is 7 greater than 0, which is also true. So that just verified what I knew, right? Again, the first and the last part are going to match. The middle part's going to be the opposite because it's a parabola. Now, you don't always know it's a parabola, though, right? So it's good to still learn how to do it with the testing of the intervals. But if you kind of already know what it looks like, then, I mean, yeah, there's some tricks involved. You don't actually have to write out every step.